Hey folks, I apologize for the sunglasses. They're transition lenses. I was just on my patio for a little bit. I forgot that they're they're pretty reactive. But anyway, let's talk about criterion validity. So criterion validity is the degree to which test scores correlate with, predict, or inform decisions regarding to another measure or outcome. So if you think of content validity as an extension to which a test correlates or corresponds with its content domain, you can think of criterion validity as similar in so much as that it's measuring or evaluating the extent to which our test correlates with or corresponds with another test or behavior or something. It's something outside the test is what I'm trying to get at here. So in content validity, we compared our test to the content domain and hoped for a strong relationship. In criterion validity, we compare our test to a criterion variable and again hope for the most part a strong relationship. Sorry, my chair does not have a back anymore. So yeah, I'm just surprised this doesn't happen more often. But guess what? We are still keeping this recording. Okay. So criterion validity is sometimes broken down a bit further into concurrent validity, where our test and the criterion are administered concurrently, so at the same time, or predictive validity, where our test is measured first and then can be used to make a prediction on a future criterion. The distinction is based on the intended purposes or the intended use of the score from our test. Predictive is for predictive purposes. So criterion validity is limited because it doesn't actually require our test to be a reasonable measure of the construct, only that it's related strongly with another measure of the construct. And I've got some nice written examples in the notes, so check those out. The book goes into detail here. These videos don't cover everything because, well, the book says it pretty well. So check those out, use all the resources. But yeah, these both these, oh look, I have notes on the next slide. Let's just go there. Okay, so concurrent validity is the degree to which a test correlates with external criteria that is measured at the same time. So for example, does a depression inventory correlate with clinical diagnoses versus predictive validity, the degree to which a test predicts or correlates with an external criteria that is measured sometime in the future. For example, does a depression inventory predict a later clinical diagnosis? So in all these cases for criterion-related evidence, it tells us how well a test corresponds with a particular criterion. I realize that it sounds like I'm repeating myself, but I'm going to repeat myself because this is a really important concept. And for criterion, it can be a behavioral outcome or a measurable outcome. It's just something that isn't the test. For example, with SAT predicting GPA is the criterion in this case. So the BDI predicting suicidality, here suicide is the criterion. And the big difference here is predicting the future or predicting the present. That's the big distinction between predictive and concurrent. So let's talk a little about predictive validity evidence. So again, it's about forecasting the future and how well does that test predict future outcomes. Most tests don't have great predictive validity. For example, SAT predicting first-year GPA. And that's because of a lot of things. One, no measure is perfect. And the longer time span you have, the lower your correlation is just going to be because of developmental changes things like that. It's the same issues, or not issues, the same kinds of challenges as test retest. The longer the span of test, the lower the correlation is going to be, even for super stable traits. And these correlations are going to decline anyway, so we have an issue with method variance. I think I've talked a little about this, but the idea here is because we are looking at two different kinds of assessments, either different kinds of tests, or one is a test and one is a behavior, they will correlate less because they do not have the same statistical, or not the same method of documentation. They do not get a bonus for a little bit of systematic bias. Now, concurrent related evidence is generally higher than predictive because you're forecasting the present. So how well does a test predict a currently similar outcome? Job samples, alternative tests used to demonstrate current validity are all ways to do this. But often these measures will be, like if it's two tests, they are implemented at the same time beyond in the same environment. So you have extra similarity because any non-random errors or errors that are random on a longer scale will be sucked in to our variance, by making these a little more impressive than they actually are. All right, so how do we quantify criterion-related evidence? Well, we got the validity coefficient, and that's the correlation between the test and the criterion. Usually these range from 0.3 to 0.6 in real life, and they will depend a lot on the measure, the construct, the span of time, and in this field, generally, if it's statistically significant, the evidence is generally considered valid. But as you've learned in your previous classes, statistical significance is a function of sample size and effect size. So you'll find a more significant result, or you will, all else being equal, a larger effect is more likely to be found to be significant than a smaller effect. Larger sample, you have better ability to detect the difference between your null and alternative, but all else being equal, if you have comparable sample sizes and comparable expected results, bigger correlation is a larger validity coefficient. Now, but recall that R squared, which is typically how we evaluate this, is different from the correlation. It indicates variance explained. And that squared means we have to effectively square the correlation between our effects to understand that proportion of variance. So in reality, what we're looking at here ranges from 9 to 36%. And that corresponds to our 0.3 and 0.6 correlations. It's not a ton. It can sound a little problematic if you think about it for a bit, but not too hard. But it depends on the construct. And so be familiar with the literature in your area to know if that R squared is big or small, because it depends. So for how to evaluate criterion-based relationships. So you're going to want to look at changes in the cause of relationships. For example, third variable effects, where situational factors during occur during validation, and these can be replicated later in the uses of scales. So check those. Check out Simpson's paradox if you are unfamiliar with what I'm talking about. So next stage is examine what the criterion really means. This, you may have heard me talk about how I think grade inflation is silly as a concern because universities have brought it upon themselves by selecting students for admission based on their predicted GPA when they graduate, their criterion is the same thing they are worried about. So if they stop selecting on predicted GPA, they wouldn't have this problem of grade inflation. Sorry, that's my little TED talk and why I think complaints about grade inflation are stupid. I would love to give all my students A's. I'm happy to, based on a criterion assessment. I don't do normative samples. I mean, it looks like I'm doing a normative sample in curves, but it's not actually. It's a way to like calibrate my criterion test or metric. All right. Anyway, yeah. So ideally for your criterion, it should be something the test is trying to measure. If the criterion is not valid and reliable, you have no evidence of the criterion being related. So if it is not a good measure to begin with, it doesn't matter if it's correlated. It doesn't matter if your criterion is invalid, unreliable, you're done. Start over, pick a new measure, or take a little break, think critically, and then pick a new measure of your criterion. Okay, lastly, you're going to want to review the subject population in the validity study. You want to make sure that that normative sample is representative, because if it is not, you have very little evidence of any kind of criterion validity. In my kind of refresher of what generalizability means, so if your normative sample does not look like, or is not at least representative of whoever you are evaluating their measures on or using to make predictions, take a step back immediately, because any inferences you draw from your test and those norms are not valid for your subject or who you are making these predictions. Be very mindful of that, because when you are drawing inferences, you are drawing them from that normative sample, that metric that is being used as the benchmark. So don't compare apples to oranges. Yes, they're both fruit, but don't critique an orange for being orange if you only have a metric full of apples that are red and green. Okay, that's my weird fruit analogy. Okay, so when you are evaluating validity, you need to make sure that the sample size is adequate because of power. You will have a much harder time drawing inferences about your sample or interpreting your standard error because it'll be wider, or your standard error of measurement, it'll be wider as a product of your sample size of your study. And it gets wider and wider if you break your sample down into subgroups. So be really mindful of sample size. Okay, next. Okay, here's my grumpiness on criterion versus predictor. Okay, here. So don't confuse your criterion with the predictor. Full stop. Because otherwise, you're going to have a bad time. Think about GREs, for example, those of you that are coming up. So GREs are used to predict success in grad school. Some graduate programs may admit low GRE students, but then require them to have a certain GRE before they can graduate. So low GRE score succeeds, and this demonstrates poor predictability. Now, I'm biased because I have some friends in the GRE section and they're wonderful people. But the GRE has some problems because of selection and restriction of range. So watch out for restriction of range. If no one is being evaluated in the low end of your range, you don't know how good your measure is. It could be great, and all that selection is just throwing out all the people who would be poor performers on your criterion. Grade inflation, for example, has this problem. They forget about this. Okay, we're almost done, I promise. And when I say we're almost done, I'm more talking to me to get me through the last like 2 slides. But okay, so in general, you should review the evidence for validity. look at them. Don't assume. And for that, you want to ask yourself about generalization. If the tests are only given in a lab setting, then do we expect them to be as valid when they're in a classroom? So I want you to think about ecological validity here, because any differences will reduce your predictive power for the most part. So think about ecological validity, and I encourage you to circle back to the Cook and Campbell approach to think about this. Now, I also want you to consider differential prediction. So just because a test is good predictive validity for the normative sample, that doesn't mean it has good predictive validity for people outside that normative sample. So external validity here, think about your samples, people. I don't know why I'm whispering. But yeah, so that wraps up criterion-related validity. I'll see y'all later.